So 7 years ago, when I was at the University of Illinois, Urbana-Champaign, which I loved the research, I loved the teaching. I didn't love, and I admire those that do this, you know, the publishing and the grant writing. And I realized I had this tremendously powerful set of tools, mathematical and statistical tools, modeling tools, and what I really wanted to do was to apply these tools, to use them. But in order to do that, I needed to find a place to practice everything that I'd learned. So, you know, to borrow from Archimedes, you know, I had a lever large enough, but I really needed a place to stand. So I found HCA after a search. HCA has a large number of patients every year, you know, 1.8 million patients, inpatients a year, 7.5 million ER visits every year. So I finally found a place that had the data and had an interest in using this data. And I realized that they had more data than anywhere else, and they had more promise of using the data to really improve human life more than anybody else. So with Edwin Jackson, who's our chief data scientist, I built and led the first HCA data science team. And we began to truly leverage the data. So we began to study clinical problems, operational problems. We built clinical predictive models. But a single team wasn't enough. I mean, this is a company which is, you know, in multiple states. We have different business units as well, and a single data science team really wasn't enough to truly leverage everything that was there to answer all of the questions. So we decided to found an enterprise data science team, an enterprise data science program, the sole purpose of which was to strengthen and to broaden the reach of data science at HCA and to improve the capabilities in data science and data science tools across HCA. So if you are here in Colorado and you want to start a data science team, I will consult with you. I'll help you figure out what might work, who might be available, how do you get started, how ready are you truly ready for data science, and what kinds of problems do you want to solve. So that's the role that I've had since the beginning of 2017. And now, as I mentioned, part of my work is to really help business units launch data science teams and data science initiatives. So in this talk, we're going to take a look at data science from a business perspective. And we're going to look at a framework that I found helpful in evaluating organizational data science readiness. It's a framework that I borrowed part of and I built a little bit more into, and which I use quite frequently. We'll look at tools that I've developed and use pretty much every day in inventorying the skills and evaluating the skills of data scientists, both data scientists that are currently in their organization, aspiring data scientists that want to grow up within the organization, and also hires that we make into HCA. And finally, we'll look at what skills are most important to organizations based on their readiness for data science. So I do happy to answer questions at any point. So if you have questions during the presentation, you can ask then, certainly afterwards. And at the end, I'll give you my email address as well. So if you have other questions afterwards, I'm happy to answer those as well. So there are many models of data science readiness. Lots of different factors that people take into account, but I wanted to have a simple enough framework that it was flexible. So organizations definitely vary in the analytical sophistication of the analyses that they do. Some don't do any. Some do very simple retrospective reports of the quality of the work that they've been doing. Some do more advanced. They actually look at the key drivers of particular outcomes. Organizations vary in the amount of workflow adoption they use of these analytical tools that they build. So some, again, it's a spreadsheet that you generate once a month. and you simply take a look at the numbers, and that's your workflow adoption. Doesn't really go into the workflow, but someone might look at it and then say, we really need to change this particular process. We need to change how patients are admitted into a hospital because we're slow. We have too many delays. All the way up to those companies that are extremely sophisticated and have real-time feedback ongoing. You can bet that Google monitors in real time the clicks that are happening, the queries that are going in. Our organization now has some that are near real time, where we monitor what's happening as it's happening and score and model based on that. So at the lower side, you have these simple analyses. This is the spreadsheet. You do it once a week. It's manual. You might do retrospective dashboards. So it's a little more automatic. It's populated. You might see what happened last month. So in the hospital setting, which I'm most familiar with now, how many hospital-acquired infections have you had over the last year? That would be the role of a retrospective dashboard. And you might get much more sophisticated. What's real-time monitoring? Tell me how many patients I have in each room in this hospital right now. I want to know where the bottlenecks are right now, and I'm taking a feed off of the live data that nurses enter when they say, I want to transfer this patient to a new room. So that's the greatest workflow adoption. Anything you get out of this immediately goes and modifies workflow. Let's take a look at different levels of analytical solutions. Key driver analyses. All right, so you are taking a look at retrospective data, but now you're going to find out which are the most important factors in determining that. Statistical modeling, a little bit more sophisticated. This is actually really powerful. So you have a theory about what's going on. So you create a model to represent that theory, and you see how well it explains what you think is going on. Causal modeling, more sophisticated still. Why did this happen? Well, with certain distributional assumptions, you can do statistical modeling that captures causal reasons. All right, let's go over here. A little bit more workflow adoption. These don't have to be adopted. These can just be early on, you do it once a month. Here, this is impacting workflow forecasting. So you're going to make a forecast, usually time series forecast, about what's going to be happening next. You might do a simple type of machine learning algorithm. You might do classification. You could do anomaly detection. These readings are not correct. There's something different about this patient. This needs to be paid attention to. You can do real-time prediction, even more sophisticated here, and you could do this in real time. Difficult to do, difficult to pull off, but extremely valuable if you can. You might do natural language processing of varying levels of sophistication. There are some types that are really just down here, like sentiment analysis. Count up the positive words and the negative words and come up with the sentiment score. All the way up to highly sophisticated recurrent neural networks that can actually translate from one language to another. In silico experiments. I think I made up this term, but I'm not sure. There's been a lot of claiming of making up terms lately, so I'm going to be very careful about that. But what the term means is you want to know what's going to happen if you change something, all else being held equal. What would happen if I change this part of the process? Or, even better, tell me what the best solution would be. Here's how much money I have to spend. Here's how much time I have. If I'm going to be putting resources towards something, what would be the best thing for me to do to optimize my outcome? All the way up to AI. By this, you have Tesla self-driving cars. It's making all the decisions in real time. There's no human component in the middle now. This also is where deep learning often gets put as well. So this is machine learning algorithms where you don't have to create the representation of what it's learning. It learns what it needs to represent in order to actually make good predictions. The most sophisticated. So what I wanted to do was to use a framework where I could actually talk about companies that most companies would understand and most parts of HCA would talk about. So I used as a basis Analytics at Work. This was a book primarily by Thomas Davenport. And the idea here is that companies can be broken up into different areas. Okay? The companies that do this type of key driver analysis, that do this type of analysis but only affect the workflow some, tend to be of a certain kind, a certain readiness. He was talking about analytics readiness. I talk about data science readiness. Then you have companies that are doing this level of work, a little bit more sophisticated, ready to adopt more of data science, get more value out of it, all the way up. He actually went so far as to label these companies, and some of them are not flattering names, but they're accurate. It's true. Okay, localized analytics. You're doing it, but you're doing it on silos of data. All right, here, analytics aspirations, you know what can be done. You have some predictive models. You're beginning to see what the value is, and you'd like more. Okay. You are now an analytical company. You're using data for data-driven decision-making. It's a core part of what you do. You do your business better because of the analytics that you're doing. All the way up to you are differentiated by your analytics. Yes, you're in a particular business, but what makes you special and what makes you successful is your analytics, your predictive model, the data scientists that you have. So that's the highest stage. So, in a large enough company, you'll actually have units that are at multiple levels. So in HCA, I can tell you, as a matter of fact, that we have companies that we have parts of the company that are absolutely stage 1. And that's when I tend to just say stage 1. I usually don't use what it's called. We have people who have localized analytics. They're using their data, but they're not actually using the wider data that's available, nor do they make their data available more broadly. We have lots of places that are in stage 3. They get it. They're beginning to share their data. They're doing deeper analytics. Then you have parts that are actually making things happen because of their predictive analytics. This we're still striving for. We're not there yet. I believe certainly that we can get there. But we have business units, areas, hospitals, divisions that are in each of these different areas. So the framework, just to give you a little bit of background on it, involves looking at data accessibility, whether you have high quality data, the enterprise orientation, whether it's believed at the enterprise level, whether you try to make things available to the enterprise, whether you have good analytical leadership, whether you have strategic targets, you know what you want to do. You have a particular question in mind. You have problems you want to solve. It's not vague. Analysts, that you have well-trained analysts that can learn. To this, I've added adoption readiness. Some of you may be familiar with the adoption curve. You need to have people who are ready to consume what you're creating. If they don't believe the results of a predictive model, there's no point in creating the predictive model. And infrastructure. You can have great models, beautiful models, but if you're delivering everything on a spreadsheet via email, you're not building a real-time system off of this. And it's going to be very difficult to implement a model that actually runs in the spreadsheets. You can do it, side note, you can do it if it's a general linear model. You can put a general linear model anywhere. You can stuff it in anywhere. But the more advanced stuff, it won't fly. So, an important question is what is the most productive and important work that a data scientist can do in organization at each of these levels? Because there is a place for data scientists even in a stage 1 organization. But what are the kinds of work that a data scientist can do in these different organizations? This is important because this allows you to choose strategically where you might go should you choose to go into data science. You want to think strategically about what kinds of companies are out there. And the skill sets that are necessary to succeed at these different types of companies differ. So let's begin and start with stage 1. So in stage 1, the most productive and important work for data science here is to let them learn about what's possible with data science. So in the analytically impaired, what's important here is to introduce analytical sophistication and to answer questions. With this company, what's most important is actually to sit down with the stakeholders, with the business owner, with the clinicians, with the people who need to make the decisions, and to find out what questions they have. A well-trained person, if they have data and understand the data well enough and understand the business well enough, can actually work with that person to do exploratory data analysis. So let's just visualize the data first. That's actually revelatory to some people because they've never gotten to see their own data presented to them in a way that makes sense before. So just visualizing the data. Second, doing some deeper analysis, cluster analysis. Here are the different types of patients you see. Here are the different types of customers. Here are the different types of groups that they fall into. And even better, to do statistical modeling. So you have a theory about patients that are readmitted? What do you think causes the readmission? Tell me your theory. All right, I'm going to put that into a model. You think that it has to do with cognitive function. All right, let's put in, let's look for these key words in the physician notes. You think that it's adverse temperature when they're discharged. Okay, we'll put that into the model as well. Now we're going to fit that model against the data that we have. Even though it's localized, we can fit the data to the model. And then we're going to figure out how many patients we missed, how many we got. And you can give them immediate feedback on how good their theory was. What did it miss? Okay, here's this whole pool of patients that you didn't predict. What else could it be? Or do you need someone to explore to figure out what's going on? Or, my gosh, you got like 90% of the patients, you're there. If you had this information in hand before the patient was discharged, what could you do? Or, knowing what you know now, what can you change about your process? So stage 1 companies, it's all about that type of discovery. There's no commitment to production. You don't have to have anything in place. It is a conversation that reveals things about the data. So the nice thing about this is it shows the value of the data. You immediately begin to understand what the return on investment could be should you decide to invest in the infrastructure that would allow you to put things into the workflow. So let's talk about stage 2. Stage 2 can benefit from simple analytics that can be implemented within the existing workflow. So here, the companies realize that there's value in the data, and if there's only a way for them to implement it, they could get value out of it. So here, the challenge is to create models, but to create simple models in simple frameworks that can be delivered. That was quite serious when I was talking about general linear models, regression models, logistic regression models. If you have software that can add and multiply, you're set. So if it's a spreadsheet, fine. I'll put it in a spreadsheet. If you have a simple dashboard which is displayed, your programmers can probably put in the little bit of additional code so we can actually implement this model that we've created together earlier and begin to realize value and begin to influence workflow at that point. Okay, you let people know before someone is discharged that they're at high risk for being readmitted. Maybe you can do something about it. Level 3. So in level 3, it's all about choosing targets because now they have some models. They have models in production. Now at this point, they have decent infrastructure to actually implement these things. So if you can come up with the ideas, then it can be implemented. So here, it's all about exploring additional opportunities, creating models around those opportunities, and delivering those models, making sure that they're available, that they're in production. And this is very much all about delivery. So this is creating solutions, delivering solutions on a regular basis. The other thing that you can do here is to begin to build even better infrastructure. As you deliver solutions that help and have an ROI and make sense, then maybe you want to deliver something that can be faster, so you don't have to wait quite so long, that maybe is interactive. Maybe you give the capability of the consumer of this dashboard the ability to play what-if scenarios there, in place. More and more infrastructure and more advanced techniques. Stage 4. So here the company has invested. They're much more sophisticated. Now they're interested in greater sophistication in the modeling. So this is where you begin to see applications of deep learning, for example. Much more comfortable with applications that actually move fairly quickly from prescription to action. So that human intervention, they're more comfortable saying, okay, I believe the model output. I don't have to see within the model anymore. It's worked. I know that we're monitoring it. I know if the model stops predicting well, we're going to be alerted about that. So yes, let's go ahead and put this more into an immediate workflow. Here is when companies begin to figure out how they can be different from other companies. They're already realizing the value of predictive analytics. Now they begin to explore what differentiates them from other people in the industry, and they start, they want to move to be differentiated by the quality of their analytics. And the trick here is you've built up a number of different products all the way through, and the trick now to move into stage 5 is to combine those products into ever more sophisticated and automated solutions. You know, where can you go that no one has gone before? And finally, stage 5, this is where you've pulled together everything you have. This is when you really invest in the machine learning talent and the data scientists that not only know the techniques, but that can create new techniques for you that are different from what other people can do. At this point, it matters a great deal whether your model is 90% accurate or 91% accurate. So this is where that extra work goes into the greater sophistication, the better models. These are also the companies that are at the forefront of data science. So when they care to, these are the companies that make the publications that make people's jaws drop. And there are also fewer of these companies. So these are the Googles, the Facebooks, the LinkedIns, whose livelihood depends on having the best models and the best analytics. So any questions about the different stages of companies? Yes?
A couple of questions.
Yeah.
Would you say that the lower stage companies are more old or more new companies that just don't know about data science?
You know, it's a variety. So within HCA, for example, these are business units that have been around for a long time. And they've managed to do what they're doing, you know, pretty well. But they're just now recently feeling the pressure to up their game. You know, other people are moving ahead. They want to get there as well. This could also be newer, smaller companies as well. So usually newer, smaller companies are beginning to think about this now, but not all. So, but yes, I think you put your finger on it. Often these can be older companies where data science is new to them, or it's something they were planning on doing but just haven't had a chance to. Remember, the problem here is that it's localized analytics. And it's, or no analytics, but localized data. So that means they also don't have infrastructure. So they don't have the large data store someplace. They're working on spreadsheets. It's shocking how many companies operate that way. I talked about my type of approach here at a data science meetup. And there are some large companies that shall go unnamed that operate pretty much off of sending spreadsheets around. And it's amazing that they can still operate, but that's what they do. So, yes. Other questions? Or another question, sure. Sure.
Do you see it often that companies will skip stages?
That's hard to do because you have to have the talent here to be able to do that. Plus, not everyone's convinced. You know, you'll have early adopters even here that where they'll be talking about deep learning, and they're sending spreadsheets. You know, they see what can happen, but not everyone's invested. There's a reason why they're still doing spreadsheets, and even here, the infrastructure isn't there. So to leap from here to here is not just a matter of sophistication. That's part of it, but it's also the infrastructure, the ability to have workflow adoption. So you kind of, you know, maybe you could engineer sort of set of circumstances where it would be possible, but that would be rare. Question? Yes?
Is there a greater risk involved going higher up the stages? So if Civic was done then, you were up the creek, or
So going up the stages, yes. So if you are not realizing value from what you're doing, certainly I can think of some companies that sort of they want to hire the unicorn. They want to hire the data scientist that's worked at Google, who knows 7 computer languages, who wrote some of the machine learning algorithms. They'll hire that person, but the company's here. Hugely expensive to hire someone like that, and difficult to keep them. If they don't have other people that they can work with, and if they don't get to see their things in production, why would you want to stay? So they invest a lot, costs a lot. They're not showing value because the infrastructure isn't there yet. So they haven't shown the incremental value. So yeah, pretty high risk. Then you also lose the person as a bonus. Other questions? All right. So the next question is, what types of skills do you need to have in order to actually work in these companies? And a later question that we're going to answer is, what types of skills do you need at the different types of companies? Because as I just was mentioning, you can be a monster in machine learning and yet fail if you're at a company that's not ready for you. So I'll give you a quick overview of this. This is a rubric that I use to do a skills inventory with data scientists at HCA and also with aspiring data scientists and also people that we're looking to hire. This is statistics and mathematics. The wording just didn't fit, so I just put statistics. Visualization, communication, storytelling, domain knowledge, which is almost just always on the job, big data. This actually refers to that specialized infrastructure for very large data sets, programming, SQL, and machine learning. So what does a data scientist 1 look like? This is actually one of our data scientists 1s. So in a discussion, figuring out sort of where they stand, this is where they fell. So they're pretty good with machine learning. They know some of the algorithms. They're good communicator. I'd be happy to sort of put them in front of a room of people. Very good programmer. But in terms of domain knowledge, they're still learning. Big data, they only know a little bit. It doesn't really matter. And statistics and visualization, they know very little. It's all right. Now, the next question is not how quickly can you learn visualization. The next question really is, what are you interested in? If you don't know very much about visualization, it's either because you didn't have the opportunity yet, or you're not interested. And if you're not interested, that's fine. The individual doesn't need to have all the skills, but the team does. So maybe you don't go after visualization. Maybe you love machine learning. Okay, great. Then learn that even more. But progress. Learn more. Data scientist 2. So they've covered a lot of ground. They still have some areas that they're stronger than others. Again, big data, not nearly as important. Most companies will say, yeah, they have big data. Most companies actually don't. So it turns out that when you actually get down to the level when you've selected the column, let's say that it's structured data. You selected the columns you want, you filter out the cases you want, it's no longer big data. It's medium-sized data. And your current laptops, even maybe a beefed-up desktop, can handle those fine. You give up a lot when you have to work in big data infrastructure. When you have to, then yeah, you really need to know Hadoop. You need to know Spark. You need to know the specialized programming languages and infrastructure, but if you don't need it, you don't have to use it. And then finally, the senior data scientist and then the monster, the consulting data scientist. This is the person that everybody thinks that they must hire. When people say data scientist, this is what they're thinking. They know everything. But actually, there are very few people. And again, you don't really need this. You need this. You need the team which covers the ground in order to solve the problems that you have. So using this, and I do this, using this you can get an idea of who to hire next. Who do you need to fill in? You get an idea of sort of what projects to stay away from. So in this case, for example, if someone has an idea of a deep statistical analysis, I'd say, well, let's give it to another team. Because this team doesn't have the chops for that, which is fine. There are plenty of other things they can do. Don't put them on something they don't have the skill set to do. Or get a consultant and have them work with the team. Then the team can learn. All right, let's look at the skills a little bit more in detail. So I'm going to go through each of the different skills. I'm going to give you an idea of what my journey looked like when I went from academia into data science and the surprises that I found there. So we're going to look at each area. It's not going to be exhaustive. The skills that I'm going to list here are just samplings of what's there. Just so you know, it's the ones that I thought were most important specifically to talk to you about. But these are some of the crucial skills I believe that a data scientist needs in order to grow. So let's look at statistics. The most broadly useful is a good background in statistical modeling. So the idea here is not a lot of training in particular statistical approaches. When I'm hiring someone new, it doesn't help so much if they know ANOVAs backwards and forwards. That's not as useful. However, if they're able to actually state a statistical model and understand how to state an interaction, that's great. Actually, that's really helpful. Causal modeling, a little bit more rarefied, but something which you can also learn as well. Linear algebra, foundational for so much. This doesn't have to be the deep linear algebra. This can be even, 1 or 2 courses in linear algebra. But if your general linear model is failing and is unstable, you have betas that are bouncing all over the place, it really behooves you to know why, and the why is absolutely in the linear algebra. Deep learning. So I was mentioning Tesla cars before, Tesla self-driving cars. You realize that in the car they have a GPU supercomputer essentially, and all that it is doing is matrix multiplies, one after the other. Either you're doing convolution or they're actually doing inferencing on the machine in real time on the images, and it's all linear algebra. Multivariable calculus, just enough to understand what a gradient is. So you understand what's going on. You don't have to do the proofs, but you have to have enough understanding so you can understand what's happening. And this is getting more and more sophisticated. Data scientist 1 all the way to consulting data scientists, right? Optimization, the more you know about that, almost all these techniques depend on optimization. So do you know what a convex problem is? If you do, that's going to help you. Bayesian statistics, you have a deep enough understanding of Bayesian statistics, and all machine learning becomes a single thing. They're all just models with posterior distributions. You can think about them all in that way. You don't have to, but if you want to be a consulting data scientist, this is what you want to eventually get to. Visualization. And actually I told you what surprised me. Yeah, what surprised me was that all that I'd learned about ANOVAs and about different types of statistical, particular statistical techniques, because I taught graduate stats classes at University of Illinois, so out of the Hayes book, so this was, good, solid statistics, and I realized I didn't get to use almost any of that. The questions that people were asking weren't in the form, and they didn't have the patience for me to say, I'm going to work with you to turn this into an experimental design. And they're walking out the door. Like, that's not what I asked you. What they wanted to be able to was to simply tell me and have me translate, and that's where statistical modeling, I realized, became incredibly useful. And that's, I've used R for a long time, but this is where it's shown. That interactive, exploratory work, especially combined with that statistical modeling. Visualization. Here, just knowing the best practices. And actually, there are lots of different best practices. There aren't just a set of best practices. There are lots of different ideas about it, but they tend to be in agreement. From the very simplest, stay away from chart junk, to be aware of the cognitive load of a particular type of visualization. So just knowing best practices, that's kind of the stepping stone, that's the first one. Exploratory data analysis, knowing what it is, knowing that it's important, being able to carry it out. Programming-based methods. So many people do graphs in Excel, or they do it in Tableau, or other tools, and if you want to do that same graph again, but just slightly different and with a different data source, guess what you're doing? Exactly what you did in the first place with no savings whatsoever. You have to recreate everything. And audit trail, can somebody come back and sort of check your work? Can you check and see if you made a mistake? Nope, because it was all manual. No savings. Programming-based methods. So this is going to be in MATLAB. This is going to be MATLAB does this well. Python has good packages. R shines here. ggplot. And finally, the really advanced person has cognitive and perceptual understanding of what's going on. Why can't you use more than 7 colors to represent categorical variables? It hurts when I do it, but I don't know why. You know, so it's just some basic knowledge of what's going on there so you can avoid making terrible, terrible mistakes. So one thing that was surprising to me here was that the visual vocabulary in the business world is far more limited than in research. So I can put a scatter plot, right? I can put a scatter plot up here, and you all will get it immediately. If it's interesting enough, you'll even say, "Oh, cool! You know, there's a nonlinear relationship there. You know, you put a scatter plot in front of the average business user. First of all, they think it's a 2x2 plot. Anybody here in business? 2x2 plot? It is not a 2x2 plot, and they don't understand what it is, and it just doesn't help. So having to translate and having to prepare people for what they were about to see and motivate it and say, this is going to answer your question in one picture, but we're going to have to spend some time actually saying what the picture is saying first, but then you're going to see it. And then I'll be able to show you the next time using the same tool, but let's look at it. Different vocabulary, and you can't assume. So I had to learn the new vocabularies. I had to do trial runs. I had to ask what they got and what they didn't get. I couldn't assume. All right, communication. This was the toughest one for me, frankly. What I look for when I'm training, hiring, is background in giving presentations, certainly, written reports as well, an accessible style. A good conversational style, so it's accessible to people. Adaptability, so you can give different types of presentations. And finally, experience giving executive presentations. So this one blew me away. I've taught for a long time. I've been in lots of different sized classrooms, undergraduate classrooms, and graduate, and lots of different venues. And you have good basic skills that you develop when you do this over time. You can read people. So I would go into an executive presentation, very senior people, I'd be presenting to them, and I could read that things were going south. I could tell that I was losing them and I was just about to be thrown out, but I couldn't tell why. Because I was giving a good presentation, I was motivating what was going to be happening, I was setting up the problem for them, and then sort of showing them how I came to the solution, and then I was going to show the solution, and then what this meant. And what someone finally, thankfully, told me was that was exactly in reverse. And actually, all that you do is you show what the results were. You put that at the very front. It's like the worst presentation ever. Here are the results. And then you're done. Because at that level, they assume you've already done all your work. And if you begin to show them the details and tell them what you've done, they read that as insecurity. This is what I did. Is it right? It's anathema to give a presentation like that at an academic conference where you just give the results and you say, trust me. And yet, storytelling. It sounds pretty squishy, doesn't it? But actually, it's critical. If you aren't able to do this, you can't really communicate your results. The idea here is that you communicate something which is approximately correct, is sufficient to allow understanding. And I realized that the best way to tell you about storytelling was to tell you a story. So I had a problem. I needed to do an analysis of patient satisfaction. The only data that was available, we had lots of different patients going in, and they said, loved it, hated it. A little bit more than that, but loved the hospital, hated the hospital. So patients are coming into the hospital, we only survey them on the way out. They wanted to know the individual units, how the individual units were doing, and they could never see how to do it because they just got the score from the patient. Well, we know where the patient went in the hospital. So My first thought was, of course, you're just going to build a logistic regression model where the predictors are the rooms that they went in. Did they visit 4 West? Yes, no. Did they visit 5 West? Yes, no. So all these different predictors, all the different outcomes, and then you do a regression, and then you put weights on 4 West. 4 West is awful. 4 West is terrible. Nurse Ratched works on 4 West. And so anybody who went there, their scores are going to be depressed. 5 West, cheery, happy. They love their patients love them. So of course you can do a linear regression, logistic regression, and see who's positive and who's negatives in the beta weight. Great. Good solution. I was very proud. How do you explain this? How do you explain to someone who doesn't even know what a scatter plot is? So I came up with this. In X-rays, we send X-rays through a patient, and then we have sensors that pick up. So this is a CT scan, and you can reconstruct what's happening in the patient in areas that you can't have direct access to, that you can't see directly, by how the signal is modified as it goes through the body. Send this through, and you get this. Those of you who are medically trained will realize that that's an abdomen, this is a brain. You get the idea. Similarly, we send patients through the hospital. We admit them, they travel through the hospital, and at the end we have a sensor. In this case, it's a survey. And it simply says whether it was a good experience or a bad experience. Their experience is going to be informed by what they traveled through. So what you have here is a CT patient satisfaction scan. You get it? Great. Let's look at the results. So that's storytelling. Next, domain knowledge. This is almost always on the job because you never know where you're going to end up. You never know what it's going to look like. Companies prefer to train you themselves, even if you're in their particular area. That's certainly true in healthcare. If someone has healthcare experience, it's great. It's a plus. But it won't make someone hire you just because you have that. So it's an added. And it's very specialized knowledge. I learned on the job as well. Big data technologies. I already mentioned big data usually isn't. You might need to have big data technologies if you have streaming data or if you have very large data sets and the only way to get to it is through these big data technologies. Now the thing is, though, if you have this experience and if you like doing that kind of work, you have a job. So if you love Linux, if you love Spark or Hadoop, if you love MapReduce jobs, I'm sorry, that's old technology. But if you love Spark, then you have a job. But if you don't love doing that kind of work, it's awful to do. Can you tell I don't love that kind of work? So really at HCA, for example, even with all the patients we have and all the data that we have streaming through, there are only a handful of projects where I really need someone with big data experience. And sometimes that's a developer person. So it's someone who's trained in computer science and they're not a data scientist. So it's a good skill to have, and some companies just require it in order to do data science. Next, programming. This is really just critical for any data science work. You're going to be doing a couple of different languages. Python and R are the lingua francas of data science. You can know one, the other, or both, even better yet. You don't have to have a deep knowledge, but you have to have done some learning about these. If you're interested in programming in big data, then that's going to be Java. The Hadoop space runs on what are called JVM, Java machines. Scala is a functional language that's based on Java. And finally, GPU frameworks. There's more and more with deep learning. You're going to, if you want to get into the field of data science and do deep learning, it's going to be the GPU frameworks you're going to want to know. So these are things such as Torch or TensorFlow. Tensors are essentially matrices, and TensorFlow is a way of distributing that work across multiple GPUs. But it does it for you, so you don't have to do CUDA programming. I was talking to somebody who had to do CUDA programming. Who was doing CUDA programming? Are they here? Yes, exactly, yeah. It's ugly, but the frameworks make it much simpler. So it's good to know the frameworks. I already knew Python. I did Python in my lab. I did R for my statistical analysis, and so that was a good skill to bring in. Python especially has gotten more legs lately because you can actually move things into production using just Python. I think R is not too far behind. SQL. Most data is wrapped up in relational databases still. And SQL is just never going to go away. You're going to need it. Even if you're on the big data infrastructure, they have SQL-like, like Impala for Cloudera. It's just SQL, but it runs on the big data infrastructure. It's a good thing to know. It's easy to learn. It's a weird language. It's a declarative language. It's the strangest thing. You declare what you would like to have happen, and then it's executed, not in order. It's executed. It might be done in parallel. It depends on the infrastructure that you're running on. People who learn SQL first and then try to learn other languages are a little bit at sea at first, and they want to keep on going back to SQL. I know how to do it in SQL. It's important to know, try not to make it your first language. Machine learning. This is one that I found that many people don't have. But the fact is, the more experience you have, the better. So one of the first things I ask is, what experience do you have in non-class projects? Did you actually go out and try to do an outside course, a Coursera course, or did you participate in a Kaggle competition? How many people here know what Kaggle competitions are? Yeah, so ever hear of the Netflix prize? This was kind of the first one. Competition was Netflix put, what, $1 million? And said, we'll pay someone $1 million if you can predict which films someone's going to order next, because this was back in the DVD days. And a lot of people competed. There was a solution, but the solution was too difficult to actually put into practice, the workflow adoption part. So it failed that, but they had a really good solution. They ended up not paying out the money, though. The Kaggle companies put data there for you to try out, and they say, here's labeled data. Here, we're holding back some unlabeled data, so you come up with a solution. We'll give you the unlabeled data. You tell us what the scores are. We'll tell you how well you are, and here's a leaderboard. So you can sort of figure out where you are. You're unlikely to win. If you win a Kaggle competition, call me if you do. But just going through the process lets you know if you like data science, because you need to engineer your own features. You need to do everything yourself. And then you don't know if your answer is going to be good or not. You get a score back. What can you do differently? It's unclear. You need to figure it out, be creative, and yet know the data and know the science behind the methods in order to do better. If that's exciting to you, that's great. But the only way you're going to know if it's exciting to you is if you try it. So I ask if people have actually done this. Then I also look for people who are well-versed in the theory. So if you've learned the surface techniques, that's good. That's a start. But do you know which machine learning approach you would use if you really wanted to have those model scores to be probabilities? Actually turns out to be really important. And most junior data scientists don't know. And yet, it's crucial to making correct decisions about the types of modeling approaches that you should use and the conclusions you can draw from the solutions that you've created. So I often will put a more senior person in with junior people because they just don't know the theory yet. And finally, deep learning expertise. It's becoming really big because it's excellent at solving problems. Convolutional neural networks were a revelation and solved problems that people thought would never be cracked. The whole idea behind a self-driving car is only made possible by these deep neural networks and convolutional neural networks. So it's going to become more and more important. All right, so any questions about the skills? Yes?
With SQL, you mentioned something about the versions. And I was wondering if you could speak a little bit more in terms of, is there a hierarchy of different versions of SQL?
The most important SQL version to learn is the one the company happens to be using. And that's about all I can say, because they're so different. I mean, Impala, which is like a subset, has some really cool analytical functions, but it's not full ANSI SQL. You know, is any distribution actually full ANSI SQL? You know, they all seem to be missing something. So in terms of what's important to learn, a variety of them. Again, it's not too bad. We use Teradata a lot, so Teradata SQL happens to be important for us, but I don't expect anybody to know Teradata SQL. What I do expect people to know is, what's a join? What's the difference between a left join and a right join? Which one is a bad idea? What's an anti-join? Anti-join doesn't exist in Teradata SQL, but if someone knows what an anti-join is, they really know their stuff. This was something that was, SQL was something which was kind of surprising me too, because I didn't know SQL. So I had to learn it coming in. Machine learning, I knew some machine learning. I knew neural networks, but I didn't know deep neural networks, because when I was in graduate school, we didn't have deep neural networks. We knew that neural networks had promise, that they could do something, but we didn't have the compute power, and we hadn't figured out that a sigmoidal squishing function wasn't a good idea. You know, we didn't have the better algorithms, we didn't have the compute. It wasn't until people wanted to start getting really good-looking games and developed graphics processing units, which we then borrowed and then started to do deep learning on, that it really took off. All right, let's go and take a look at specific mix of skills in the last few minutes that we have that are important for companies of different sizes. First of all, stage one, what do you need to know? You don't need to know any big data. You need storytelling, communication, and statistics. Answer questions, sit down with people, do exploratory data analysis, turn their theories into functions, into models that can answer their questions. Stage two. This is even more statistics, storytelling, and now programming becomes more important, because now they want to begin to see these things in production. Stage three. All right, they've got it. Other people in the team can handle this. This may or may not be important anymore, but you really better know programming. Machine learning becomes more important as well. Statistics is still important. Programming, because they've seen what the solutions are, they want them implemented, and if they're a stage 3 company, they probably don't have a big development shop. So guess what? You're it. If you want to see your models implemented, you're probably going to be the one doing it. Stage 4. This is where machine learning is just so important, because at this point they want more and more sophisticated analyses. They want to move from that 0.90 AUC to 0.91 because it makes a difference for them. And the only way to do that is if you really know your stuff with machine learning, you understand your statistics and programming. SQL actually starts becoming less important because you probably have a development team that's getting you the data anyway. And finally, up here, this is where you just need the monsters in machine learning and statistics. Statistics here because you want someone who's probably a Bayesian thinker, well-trained in Bayesian. Statistics so they can look at machine learning and it's like the Matrix. You know, it's like, there is no real difference between gradient boosting and machine learning, and they all exist together. You want to have strong programmers, and at this point you need domain knowledge, because these companies want to understand not only what they do, but what their competitors do, and to find out what's missing in the market and for you to build it for them. So this is where the creativity, machine learning, statistics all come into play. So, brief note in choice of projects to do. The idea here is in selecting projects to work on, you always try to move up in sophistication, make the case for it, then move over, so it requires a little bit more workforce and workflow adoption. All right. So, we're really, even at this point, we're early in our path to growing data science across HCA. But what we're doing now is we're doing mentoring, we're doing training and developing internal talent, we're doing strategic hiring, and now partnering with world-class educational institutions. You know, I believe that we're going to be able to change healthcare, not just at HCA, but really for everyone. And I'll finally get that opportunity to move the world. Thank you very much for your time and for your questions. And I'll be happy to take any other questions you have. What questions do you have? Yes?
Supplements to skills, personality traits, things of that nature, softer, more nebulous sort of things. Is there anything that you've got to look for?
Yeah. Again, so those are sort of off book. Yeah, you're right. So someone who, if I'm looking for someone to be a manager, for example, those skills become very, very important. But that's almost a separate track of evaluation. For hiring, I do ask about teams. You know, have you enjoyed working on teams? Can you come up with a positive example where you've worked on a team? Can you come up with a negative example where you've worked on a team? How'd you fix it? What'd you do? So those are important, but these are the necessary qualities. Other questions? Yes?
Do you think that, well, do people hire data scientists that don't have any, like, industry or business experience?
Oh, yeah.
Because since it's such a new field, I feel like I don't have enough time to get experience between graduating and
Yep.
getting a job without being...
Yes, all the time. What's most important is that you've tried out data science. So that's where the Kaggle competitions are important. We know that graduate students are really good at learning. And that's actually pretty important because it's always changing. There are always new techniques, new programming languages, new infrastructure. So you have to be constantly learning. That's one thing that we do at HCA. So about 20% of every data scientist's time is spent learning new things. So we'll be ready. You got a question?
Are there any specific challenges in the data science being implemented in healthcare as opposed to a non-healthcare industry?
Oh, definitely. So we had an opportunity to meet with some graduate students and some of your data science TIP fellows, and had very good conversations about the ethics of predictive models in healthcare. So what if you get to that level where you're an AI and you have very little human intervention between what the model says to do and doing it? What if the model's wrong? So you have I believe you have a moral obligation to make that model as transparent as possible, to make it understood by the clinician as much as possible. You also have a moral obligation on other things as well, to monitor the model for drift. Drift is when you've trained it on a particular set of patients, of people, but the people begin to change because the treatment begins to change. Maybe the hospital starts seeing a younger population. Something's different, and all of a sudden, that model is not as good as it was before. Well, if you are doing clinical models, you have an obligation to monitor that and to see when that happens. You have an obligation to see that infrastructure that supports that model is bulletproof. If you have something which says this patient is in danger, and the model stops scoring, and clinicians have become dependent on that model, at no point can that model simply go down, or the infrastructure. It needs to say not scoring. So there are other considerations that you simply don't have in other areas of business. I agree. Yes?
Can you share some favorite examples that your teams have solved, theories they've revealed to be true or not true, or things like that?
Yeah, absolutely. So it's often solutions that we have. The theories can sort of come, they're not the primary. The one that I'm really happiest with was sepsis prediction model. So, sepsis is a condition where you have a blood-borne infection. It causes a chemical cascade. You begin to bleed throughout your body. So your blood pressure goes down, organs begin to die. Mortality is extremely high if you don't catch it early. And often, if you think about how you identify sepsis, it's when the patient, is either too cold, too hot, or white blood cell counts are too low or too high. They're clammy, mental confusion. Well, at that point, things have already started to happen. So our chief medical officer, Dr. John Perlin, likened it to sepsis detection or sepsis treatment right now being when the house is on fire. Oh, where'd he go handle that? So what about smoke detectors? Can't you detect signals before the person enters sepsis? Answer is yes, you can. It turns out that even just by putting in place the process that would automatically check the vitals and check this information in an automated way was already life-saving. And so that's actually what we're rolling out into production right now, is just the detection. And when our physicians are ready, then we'll say, let's gain another 4 hours on that, and we'll start doing the predictive model. Yes?
What difference do you see when you hire a recent grad PhD between a postdoc?
Oh, so could you repeat that? I'm sorry.
What difference do you see when you hire or interview a recent grad PhD or a postdoc, someone who did a postdoc?
Okay. So, well, the interviews are I sort of treat them all the same. For our human resources department, a PhD doesn't count as work experience. But I know that the person has deep experience in a particular area. But because it's school, they don't count it as work experience. But I do weight it, especially if you've learned techniques while you were in school. And as I said, I know PhD students know how to learn. So the interview process is very similar, but I know that a PhD student is going to be walking in with some of these skills in hand. You probably had to learn programming to solve your problems. You've probably been munging data for years. You certainly know how to think about problems and how to state them, so that essential part of storytelling, which is very difficult for people to learn, is there. So I assume those things are there, sort of, test to make sure they are, but I love PhD grads. But it's not necessary, but I do love PhD grads. Yeah. Other questions? All right. Well, we're a little bit past time. Sorry about that. But thank you very much for your time and for your attention and for your questions. I appreciate it.